Hey, it's Dr. Asatar Bear, and in this lecture, we're going to be talking about resources, technology, and how a economy or a society goes about maximizing its economic output or the wealth that it produces. Okay, so maximum output. All right, resources, technology, maximum output. This is called other things. Sometimes this is called productive efficiency or simply efficiency. Uh, the maximization of income or of GDP. There's different terms that are used to describe the same thing. All right, but in terms of this argument, right, this goes back to Adam Smith, uh, classic work here, The Wealth of Nations, and this is really an argument about how does a society produce the utmost amount of wealth that it's capable of producing, right? And this argument that Smith makes is taken and developed by others, by Ricardo, by Mill, by Marshall, by many others working in the neoclassical tradition. And this is where they collectively end up. Okay, so now remember, neoclassical economics, microeconomics, is a highly mathematical theory. The language of it is mathematical, even though Smith did not use that language, right? He wrote sentences rather than using equations or graphs. Uh, However, that later that argument has been formalized, and so in order to understand it, we have to do a couple of terms. Okay, so the first thing we need to talk about is resources. All right, also known as inputs or sometimes called factors of production. Right. So, following Adam Smith, typically economists have divided this into three different uh, resources. Right. So, and these are land, labor, and capital. Right. Land, labor, and capital. Um, we're just going to, just for simplicity, we're not going to talk about land. We're just going to talk about labor and capital. All right. So those will be our two resources, and we're going to use capital L to stand for labor and capital K to stand for capital. All right, so let's just define these things. Okay, what do we mean by L? We mean the number of hours of labor, right? Now, if we're talking about this as a resource in society, then we mean, okay, what is the total number of hours of labor that are actually available? Uh, right, and obviously that depends on the population and so forth, how many the members of the population are capable of working, how many hours are they capable of working, how long is the day, et cetera, right? So let's just say that we have this number and it's represented by L. Okay, so now capital K, we're going to think of that as being the number of units of physical capital. And again, if we're talking about the entire society, we mean about how much total physical capital is available. Okay, so now physical capital, what does that mean, right? Well, this means things which are used to produce other things, right? So you see, used to produce, right? And typically, when we talk about that, right, what is used to produce, we mean things like tools and equipment, machinery, etc. Right? So productive capital or physical capital. Now, you might be wondering, what are the actual units, right? All I said is the number of units. Um, this is actually an issue in neoclassical economics. What are the units of capital? There are no natural units of capital. That's kind of the problem, right? Labor, it's a little bit different because every form of labor that we can think of, whether you're digging a hole or you're repairing a computer, whatever the form of labor is, right? There's many of different concrete forms of labor. All of these take place in time, right? So a time unit like hours is a natural unit to use for labor, right? But that's not exactly true with capital, right? There is no There's nothing that we can point to that says, oh, this is the common element that all forms of capital share, right? Um, there is no, we're not living in a Lego world or something like that, right? Where everything is built out of Lego bricks or something. No, there is no natural unit of capital. So we're going to return to that point later on, right? Just remember that for now. Okay, so labor and capital, these are our resources. Like I said, we're going to abstract from land. We won't use that in the analysis. We'll just assume that land is included in this. Okay, so these are our resources. Now, the next thing we need to describe is what is the relationship between these inputs in society. Okay, so resources or inputs or factors of production. What's the relationship between that? Okay, the inputs and the amount of output that we're able to get from that, right? So what do we mean by output? What we mean by output is the finished goods. All right, finished goods. So let's imagine that a society, let's kind of simplify things, right? And imagine that society produces, okay, so say society produces two finished goods, right? Two kinds of goods. Now I know this is pretty unrealistic, right? It's pretty stylized. We do this just to make it easier for ourselves. The analysis doesn't really require it. It's just a simplification. Okay, so two goods. All right, and we will look at the quantity of these two goods like so. Okay, let's call them good one and good two. Okay, so these two quantities, Q1, stands for the quantity of good one, right? And this Q2, of course, quantity of good two. All right, so here's our question, right? What's the relationship between these, right? We have these resources in society, we've got labor and capital, and we're going to take them and then produce finished goods. What is the relationship, right? How much output are we able to get given our inputs, right? Now, this relationship is very, very important, right? Because it has a lot to do with society's productivity, right? It's a representation of that, right? The relationship between inputs and outputs. I mean, you could say this is the cornerstone of productivity. We can call it technology, okay? It's technology in the broadest possible sense, right? It's technology of how to actually produce, right? We can take our resources and we can get the things that we want and need out of that, but at what level, right? How good are we at producing output given these inputs, right? And you can see that has a lot to do with, well, how productive is the labor? How productive is the capital, right? As we get better at producing over time, right, that with better technology, okay? So this relationship between input and output is enormously important, okay? And in neoclassical economics, microeconomics refers to this relationship by a mathematical function, okay? So this is called the production function, right? The production function represents a mathematical relationship between output and how much labor and capital has gone into it. Okay, so the production function, again, we're going to depict it in general like this, okay? We're going to say the output, Q, right? Remember, that represents output, that's finished goods, is equal to, it's a mathematical function of the labor and the capital that went into it, okay? So the inputs or the resources, okay? The inputs or the resources represent the independent variables, all right? These are like our X variables, okay? The output represents our dependent variable. That is like our Y variable, okay? So dependent variable and two independent variables, all right? Now, if you're wondering what is the exact nature of this function, we're not going to get into it that much in introductory microeconomics, but I'll just give you like a famous example, right? There's a class of production functions, which are known as the Cobb-Douglas production function, and this is a function which has this kind of form, right? We've got Q output equals labor. Let's say the labor is raised to the 1/3 power times capital raised to the 2/3 power. Okay, so just that this is an example of a mathematical function with these two variables. All right, so the point of this is, right, whatever our function is, it doesn't have to look like this, but this is just an example, right? There's lots of different, there's an infinite number really of different functions that can fit into this format, right? Well, what I've done here is to give you the general form of it, right? Versus this example is a specific form. Okay, so the specific form is going to depend on, well, whatever it is that we're producing, right? Like we could imagine, in our example, we've got two different goods, right? Good 1 and good 2. And we could imagine that each one of these has a different production function, right? There's a function which depends on, well, how much labor and capital is put into that area, right? The production of good 1, right? L1 and K1, versus Q2 is a function of how much labor and capital is placed into that kind of production, right? That industry. Okay, so we've defined our terms now, right? Our independent variables, labor and capital, L and K, and then we have the production function, which represents the relationship between them. Okay, now we're going to make a couple of more assumptions here. Okay, so these are assumptions that we'll explore more as we go into it, right? But here's what we're going to assume. Okay, so we'll assume that, let's just imagine, right, that the society is very focused on the same issue that we are, right, which is what is the maximum amount of output that the society can produce. Okay, so imagine this, right? Imagine that all the resources, okay, all of our labor and capital, for example, goes into just one area of production. Okay, it goes into producing Q1. Okay, so if all of our labor and capital goes into that, and everything is being used to its utmost, right? That is, we're producing in the very best way that we know how, right? So all of our labor and capital go to producing output good 1. Okay, we are going to have a maximum amount. We're going to have a maximum possible Q1. Okay, that the society is capable of producing, right? And imagine if we also did this, right? So this would be one point on our that's possible. Okay, so if we were to draw a graph of this, okay, where we have Q1 and on the horizontal axis here, and Q2 on the vertical axis. Okay. Now, just to make this a little bit more specific, okay, let's imagine that Q1 is like berries, right? Berries. How do you produce berries? Well, you pick them, right? So this is the number of pounds of berries. Okay. So, and then Q2. Let's say that Q2 is meat. Okay, again, in pounds. All right, so we've got two goods, berries and meat. Okay, so they come out of two different kinds of production, right? So I'm trying to pick an example that is simple example, right? Like, the first human societies did hunting and gathering, right? Long before the development of agriculture even, right? Hunting and gathering. Okay, so labor that goes towards gathering produces berries. Labor that goes towards meat production, hunting, right, produces meat. All right, we've got these two different things. Okay, so let's imagine that the maximum number of berries, the amount of berries, we'll call it point A right here, right, that the society can produce if everyone gathers, right? Everyone gathers berries, and they use all of their capital to gather berries and so forth. Let's imagine that number is 2,000 pounds. Okay, so there we have our point A. All right, and then okay, so 0, 1,000, 2,000. Okay, that's our graph. And then we would also have a commensurate amount on this side, right? I say, all right, listen, we've tried all gathering berries, and we know we can produce 2,000. Now let's all try hunting and see how much meat we can produce, right? So that is, we would have a maximum production of good 2 that's also possible. Okay, so let's say that this scale is similar here. Okay, imagine that amount is, let's say, 1,500. Okay, there's point B there. And then imagine that the society has done this again and again in different configurations. They tried out, okay, well, what if we do something in between, right? These are our 2 endpoints, right, A and B. But isn't it possible that maybe we could take some of our labor and allocate it differently, use it to okay, everyone is gathering berries right here, but let's just take a few people and we'll put them over into meat production, right, hunting, and see what happens. Okay, so let's imagine that we do all that, and what we end up with is a graph or a curve that looks like this. All right, so, and what this represents is all of the possible different combinations that we can produce in the society. Okay, and this curve has a name. It's called the production possibilities frontier. All right, the production possibilities frontier, because that's pretty long. We give it a little acronym, call it the PPF. All right, production possibilities frontier. Again, what does it represent? It represents all the points which are optimal, right, in the sense of that we have produced a maximum amount of output that we can, right, given our 2 things, okay, our resources and our technology. All right, our resources and our technology. These are the things which drive society's ability to produce. Okay, so very, very important cornerstone concepts in neoclassical economics: resources and technology. Okay, so societies, just to restate this, okay, so society's output is ultimately driven by 2 factors. Okay, so remember what we mean by output. We mean Q1 and Q2. Okay, we've just limited ourselves to imagine that the society produces only 2 goods. We could extend the analysis if we wanted to, but just this is good enough for our purposes. Just keep it simple, right? 2 goods. Okay, that's society's output, representing all the there's different possibilities, right? Because like I said, we could be at point A, we could be at point B, we could be somewhere in between, right? But the main thing is it's driven by the amount of resources, okay, L and K, on the one hand, and the technology, remember, that's represented by the production function, okay, Q equals F, parentheses, L and K, okay? So output is a function of labor and capital. The exact mathematical function, if it looks like this, for example, right, then we have a specific form of it. But if we want to just keep it general, we could say, okay, we know that there's some function out there that represents this relationship. Okay, we're going to call that the production function. All right, there's our production possibilities frontier. Now, a couple of things follow from this, right? So first of all, we've done something that's very, very important, right? Remember, the theory is focused on what does it take to produce the maximum output, right? So what this represents, the PPF, represents a picture of that, right? It's a picture of the maximum output. Okay, so if we discuss this curve in general, there's a couple of things which kind of jump out at us, right? Which we can explore. Okay, so first of all, what we notice is this has a negative slope, right? So Negative slope. All right, negative slope. Now, this has a meaning, right? This has an economic meaning. What the meaning of it is, like we must give up something in order to gain. Okay, we must give up something in order to gain. Now, if we consider what that relationship is, right? So let's imagine that we were at point A, right? That's our maximum, okay, 2,000, right? And we said, all right, we're producing 2,000. Remember that this represents the berries over here. We have the meat, okay? So we're producing 2,000 pounds of berries. The only problem with that is berries are, they're only so by themselves. What would make this really a lot better is if you had it with some meat, right? So we want to allocate some of our labor and capital. We like berries, but we would like to have a little bit of both. In other words, we want to move to another point, right? So we define these 2 points, right? A and B. We want to move from point A to point C, right? Now here's the thing, right? If we do that, we're going to have to, okay, so A to C, what has to happen here? Well, we have to take labor and capital out of producing berries, right, and into producing meat, okay? So out of berry production, and they have to be put them into meat production, okay? So, and this is called the reallocation of resources, right? We have to, instead of taking all of our labor and capital and producing berries, we've got to now take some of it and produce meat instead, okay? And so if we take out some labor and capital, right, assuming that the level of technology is unchanged, right, well, then there's going to be a loss, right? So we are going to have a loss of berries, okay? And of course, on the plus side, we'll have a gain of meat, right? Loss of berries, gain in meat, right? Now, this produces a negative slope, right? Because we're going up on one side, but down on the other side, right? And of course, this wouldn't matter, right? Well, whether we were going from C to A or A to C, I mean, we would, if we started at C and we went to A, then this side would be going down, this side would be going up, right? But the point is, if it has a negative slope, what it's expressing is there must always be something that you give up anytime that you gain, right? And the concept here is of a trade-off, right? So much like a market or any kind of exchange, you have to give up something. If you're making a trade, right? You say, okay, I want this good. Here's the money, right? You don't get to, I'm going to keep my money and this good. That's not a trade, right? That's not a market. That's just taking something, right? So what the negative slope here represents is the trade-off. Okay, now the actual slope of it is the terms of the trade. Okay, so the how steep is the slope represents what's called the opportunity cost. Okay, so the first point is, right, if there's a negative slope, there's always going to be a trade-off, right? That means that opportunity cost is always present. Okay, opportunity cost is always present. Now, the concept of opportunity cost, okay, let's just define this. Opportunity cost means, it's the same thing that I've been talking about, right? It means, what do you have to give up in order to gain something, okay? So the true cost of anything, right, is what you must give up in order to obtain it. All right, so this is whether things have a price tag or not, right? Let's say that we're not even dealing with prices. Let's say that you're hiking in the woods. You're miles and miles away from any store or market, and yet there's still opportunity cost, right? Because you're going for a hike, let's say this happens. You're hiking along a path. Here's a path. You could go to the right, or you could go to the left, right? Well, what is the cost of going there? Well, isn't it free in either case, right? I mean, you're hiking after all. It's free. You're just enjoying nature. Yes, in that sense, it's free, right? But if you go to the right, that means, of course, that you could not go to the left, right? So that is represents your opportunity cost, right? There's always something that you're giving up in order to do something else, right? That there's a limited amount of time out there, right? You're going to hike. You're not going to go on both of these, right? You have the time that you have, right? Even if you said I'm going to hike on this trail and then I'm going to go back and hike this one as well, right? Well, there's other things you could be doing with your time, right? So there's always something that you're giving up, right? So the we measure the opportunity cost by the next best alternative. Okay, so it's all right. Again, I think you guys get the idea, right? The what you must give up in order to gain. Okay, so we can actually measure the opportunity cost here, right? So we can say, look, if we're going from point A to point C, okay, we need to throw in a couple more numbers, right? But let's say that what happens in terms of berries is we go from 2,000 down to 1,800, okay? However, we go from 0 over here to, let's say, 500 on this axis, right? So the opportunity cost representing the loss that we experience relative to the gain that we experience, right? Because look, the language of opportunity cost, it's called cost, right? That tells us it's like what do we have to actually give up in order to gain, okay? So the loss, right? We started at 2,000, then went to 1,800, right? The loss in this case is the negative change over the positive change, okay? So the change in good 1 relative to the change in good 2. Now, opportunity cost is always the loss over the gain. So that means if we were going the other direction, if we were going from C to A, it would be the change in good 2 over the change in good 1. So in other words, we're always going to put the loss on top, all right? So in this example, the loss is 200. Now we're just going to put a little negative sign in front of that, okay, just to indicate that it's a loss, okay? The gain is 500. Okay, so negative 200 over 500, when we do the math, we get negative 0.4, all right? So the opportunity cost, negative 0.4, all right, what does that mean? That means for every pound of meat that we gain here, right, we give up 0.4 pounds of berries, okay? So that would be how we would interpret it, all right? So for each pound of meat gained, we must give up 0.4 pounds of berries. All right. That would be we put the opportunity cost into a sentence. All right. Now what we notice along here is there's an actual curve, right? This is not a straight line. And if the opportunity cost has something to do with the relationship between the loss and the gain, we might be able to see that that relationship does not stay the same, right? That's the meaning of it, right? If it's this steep between these 2 points, we can see it's less steep and less steep as we go along this curve, right? So the slope of the production possibilities frontier represents this opportunity cost, okay? It's going to be either the slope or the inverse of the slope depending on which direction we're going, right? If we were going from C to A, right, this would be the loss. Okay, let's just do that one. Okay, so C to A, again, the opportunity cost represents the loss over the gain. But if we're starting at C, we're starting at 500 and going down to 0, all right? So that's a negative 500, right? and we would have a gain on this side of 200. Okay, so negative 500 over 200 gives us negative 2.5, right? Now, interpretation, what does that mean? This means if we are at point C and we were going to point A, right? That's our situation. For each pound of berries that we gain, we give up 2.5 pounds of meat. All right. So which way that we're going, there's going to be a different relationship between which one is loss and which one is gain. Okay. So to summarize, the concept of opportunity cost, it is going to be either the slope of the PPF or 1 over the slope, depending on which direction we're going, right? Which direction that we're going, because that signifies which one is loss and which one is gain. Okay, but in general, opportunity cost is always the loss relative to the gain. Okay, so very important. All right. Now there's a couple of other things that kind of jump out at us, right? So like I said, we look at the production possibilities frontier, we can see it's got a negative slope. We can also see the slope changes along the curve, right? So the fact that the production possibilities frontier is curved indicates that the opportunity cost changes along the production possibilities frontier. All right, changes along the production possibilities frontier. There are some detailed technical reasons for this, which we'll get into later in the course. But for now, let's imagine that the resources cannot be transferred from one to the other totally seamlessly, right? Like, in other words, let's say that the resources are committed to one kind of production. Okay, and they're committed to. So an example of a resource being committed is, let's imagine that we have skilled hunters or gatherers. All right, remember our example has to do with hunting produces meat, gathering produces berries. So if there are skilled hunters or skilled gatherers, well, if we transfer them to the other kind of production, they're not going to produce as much, but there's going to be a big loss, right? You take your best hunter out of hunting and they're just an okay gatherer, well, you're just going to, hunting, the meat production is going to take a big hit, but the gathering production is not going to rise as much, right? So that produces a differential, right? And that's one of the things that can give rise to a curved production possibilities frontier, right? So the curve indicates the opportunity cost changes. It is not static along its entire frontier. Okay, so we can also use this to define a couple of other concepts again. Let me just draw this one more time. All right, so PPF. Okay, so again, what the production possibilities frontier represents is the maximum output, right? And we can define that as productive efficiency. Okay, the maximum output given our resources and our technology. Now, that also enables us to see very clearly, well, what would be below that, right? What would be below the optimal, right? So maximum output, productive efficiency. This is often called optimal, an optimal situation, economic theory, right? Optimality. What would be below that, right? Below optimal means suboptimal. Okay, so any point, like if we were to choose a couple of points, right? Point A, point B, point C, all of these points, as long as they're along the curve, represent efficient points. Okay, so points A, B, and C are all optimal, right? Even though they represent different levels. Okay, so look at this, right? A has the most good 2, right? That is, if we move from A to B, we're going to see a loss in good 2, but we're going to get a gain in good 1, right? And if we move on to point C, we're going to have to see a further loss in good 2 in order to get that additional gain in good 1, all right? However, all of these points are optimal because they all represent the best that society can do given its resources and technology, okay? Now, it should be obvious, right, that if this is the most you can produce of good 2, given that you're producing this amount of good 1, well, what if you were producing that same level of good 2, but you were producing less of good 1, right? That is, you're somewhere inside the curve, okay? Let's say you're at point D, okay? Point D, along with any point inside the production possibilities frontier, the PPF, is suboptimal. All right, suboptimal. That means it's inefficient. Okay, it doesn't represent a maximum in terms of output. Okay, so society could be producing more than that, right? Now, here's the thing. Of course, the society always has the option of doing worse than its best, right? Just like you or I, we could always do worse than our best, all right? We can't do better than our best, right? Our best represents, the absolute, most we can produce or whatever, right? We can't do better than that, but we can do worse, okay? So society always has the option of producing less than its maximum, right? And that's just inefficient, okay? Now, what about a point that's outside of that, okay? We're producing the same amount of good 2. Here's our maximum output of good 1. Let's say that this is 1200 over here, and this is 800, all right? But could we produce that same 800 and also produce, let's say this is point E, some amount more, like 2000, right? Well, no, that's not possible, right? Because we've defined what society's maximum is. It's along this curve. That means anything outside of it, it's not possible, okay? So point E is not possible, all right? It is, in other words, it's not attainable given society's resources, okay? So we can move along the production possibilities frontier, right? So we move along the PPF. What is society going to have to do? Well, if we want to move from, say, point C to point B, we're going to have to take resources, labor and capital, out of Q1 and put them into Q2, okay? That's called a reallocation of resources, all right? Now, society can do that at any time, right? We can have, okay, there's less people produce good 1, more people produce good 2. That's a reallocation of resources. We can do that, okay? Now, some of the capital might not transfer, right? Like I said, right, there's a reason it's curved is because maybe some of our resources are committed to production, right? So I talked about labor, right? On the labor side, we have skilled hunters and gatherers. It's also possible that we could have some committed resources on the capital side, right? So remember, reallocating resources means that we are taking both labor and capital out of the production of berries and putting them into the production of meat. Now, not every kind of capital is going to transfer the same way, right? So, like imagine, right? You have, let's say, you have a basket versus a bow and arrow, right? Now, these would be pieces of capital, right? These are things which are designed to produce other things, okay? So, is having a basket helpful if you're gathering? Well, I imagine so, right? I mean, otherwise you're like, okay, how many berries can I fit in here? I mean, you're pretty limited, right? If you have a big basket, oh man, I can carry a lot more with a basket, you know? So basket is very, very helpful for gathering, but is it helpful for hunting? I mean, what are you going to do with your basket? kill an antelope with it or something? Pretty difficult. I don't know. That's not going to really transfer, right? I mean, that's helpful in here, but it's not all that helpful here, right? That is taking that to hunting. It's not going to be as much of a gain, right? It's not going to be as helpful, okay? And the same thing with the bow and arrow, right? Very, very helpful for hunting. My God, right? This is fantastic. Have you ever tried throwing an arrow by hand? How far can you throw it? Can you throw it hard enough to kill something? Uh, I mean, don't try that, but use your imagination, right? Um, versus shooting a bow. You guys ever shot a bow? My God, it's no comparison, right? I mean, you can shoot an arrow with a bow way further, way harder uh, than without it, right? So, but see, this is not going to transfer very well to gathering, right? You don't need to shoot a berry; just pick it up, right? The bow and arrow is going to do nothing to really help that. Um, okay, so these are the capital might not fully transfer one to the other, right? That's another reason why we would get a curved production possibilities frontier instead of having it be a straight line all the way. Okay, so we can reallocate resources that would move us along the production possibilities frontier. There's nothing we can really do to get outside of it, right? That given our resources and technology, that's our limit. Okay, we can always be inside of it, of course. That's attainable, right? Any point on here, as long as it is up to the production possibilities frontier, is attainable. Okay, only the ones along this curve are efficient. Anything inside is inefficient. Anything outside can't actually be judged on its efficiency because you can't possibly get to it, right? Like, okay, so the next thing to explore here is how might this change? Okay, so if it is resources, right, that is labor and capital, and it is technology represented by the production function, Q equals a function of labor and capital. If these things together drive the position of the okay, they lead to the production possibilities frontier, right, which is a representation of society's efficiency, society's maximum output, right? Well, then it would stand to reason that a change in resources and or a change in technology, okay, this little triangle is delta, right, change in, a change in resources or technology is then going to lead to a change in the production possibilities frontier, okay? And we would depict that by showing it as a shift in the production possibilities frontier, okay? It's a shift in the PPF. It's caused by a change in resources or a change in technology. All right, so imagine we started off, okay, Q1 and Q2, we had a production possibilities frontier that looked something like this, right? But over time, we got more resources and better technology, let's say, and so the production possibilities frontier would shift out, all right? And that would give us a new collection of points, okay? So the initial production possibilities frontier, PPF1, and the new one, PPF2, after this shift, okay? So society's ability to produce stuff, to produce wealth, has been enhanced, all right? And this would be due to a change in resources or a change in technology or both, okay? So society can produce more, right? More output, okay? And we would call this, by the way, we'd call this economic growth, okay? So neoclassical economics is very focused on a particular explanation of economic growth, okay? Sometimes this is, okay, so the economic growth, according to neoclassical economics, comes from the production side, okay? So production is also sometimes called the supply side, okay? So we will return to this when we talk about supply and demand, right? So there's, broadly speaking, right, production and consumption. So consumption represents the demand side, right? It's the spending or the use of the items that are produced, whereas production is, again, that's the side where it's produced. Okay, so neoclassical economics is very, very focused on production. Okay, so one term for it sometimes is called supply side economics. This is a kind of term that came into use like back in the 1980s. Supply side economics, because of its great focus on resources and technology as being the ultimate cause of economic growth. Okay, so again, to try to draw a connection between this and what we talked about earlier, essentialism and so forth, these are the essences, right? So the essence, the reason why the output is what it is because of the resources and the technology, right? Those two things are very, very important in neoclassical economics, right? They see that is the essence of society's ability to produce, okay? So very, very important, all right? This shift in the production possibilities frontier represents something incredible that's happened here, right? Society is capable of producing more, okay? Now, we haven't talked at all about the third aspect of the economy, okay, which is distribution. Okay, so production is how and what is produced, okay? Consumption is how are these things used, right? Distribution is the topic of who gets what in society, okay? So how much of society's total output, total wealth, am I going to get? Are you going to get, right? That's distribution, okay? We haven't talked about who gets society's wealth here at all. If our resources or our technology shift or change in a way that only affects one area, not the other, then we're going to get a kind of rotation of the production possibilities frontier, okay? So if it affects only one side, right, Q1 or Q2, then only that side is going to shift. Okay, so let's do some examples. Okay, so let's say we have a Q1, Q2. Okay, let's say we have something like this happening, right? A shift in the production possibilities frontier, which changes the maximum level of output on the Q1 axis, but doesn't change it at all on the Q2 axis, right? So what would this be? This would be like, I don't know, let's say I mentioned baskets before, right? Baskets are invented. Oh, this is fantastic. Well, we don't have to just put the berries in our hands like this. We can put them all in this basket. We can carry a lot more. We can it's going to boost our gathering output, right? So, right, what does this represent? Well, this represents a change in technology. Okay, so if that's what it is, right, a change in technology, but that only affects this area, it's going to only shift the curve on that axis, right, on the horizontal axis. Okay, versus let's imagine that the shift occurs in the other area. Okay, so then we would have, for example, something like this, right? So the maximum output has changed on the Q2 axis. Okay, so this would be like, the bow and arrow would be invented, let's say. Okay, again, not real helpful for gathering, but very helpful for hunting. Okay, so Q2 is the meat and Q1 is berries. All right, so if we have only a change on one side, we're going to have a shift like in this manner. Okay, we can always measure the opportunity cost. In terms of the slope or the inverse of the slope, right? Very, very important concepts that come out of neoclassical economics. Remember, the theory is very focused on how does society produce the maximum amount of output, and so we want to formally describe that, right? What is this maximum output? Where does it come from? Okay, and the theory is going to have more to say about the production function. We're going to explore that in a lot more detail as we go through the course. But first, we're just going to use this to create our foundation of prices. Okay. Now, the production possibility frontier has also been used to provide a justification for trade, and particularly for free trade. Okay, this is called the theory of comparative advantage. All right, and it's an argument used to argue in favor of free trade. Now, whenever we're talking about this, what do we mean by this free trade? We mean that any kind of tariffs or quotas or any kind of restriction on trade of any kind, right? Sanctions, get rid of it, right? You shouldn't have tariffs, or if you should, you're going to be at the lowest possible level. Quota is a limitation on trade and so forth, right? Get rid of all these limitations, okay? And this argument comes from Ricardo. All right, Ricardo, another important figure in classical political economy, which later morphs and develops into neoclassical economics. And this part of it, Ricardo is really remembered for contributing to. Okay, so in order to understand it, right, let's imagine that we have two societies. All right, two societies, and they have two very different production possibilities frontiers. Okay, so we will call these two societies Hunterville and Gatherland. Right, neighboring societies. Okay, so we had Q2 and Q1, and these societies are good at different things, right? Hunterville, they're very good at hunting. They're not as good at gathering. Okay, so their situation is, let's say, kind of like this. Okay, so they have a production possibilities frontier that indicates, well, if they produce meat, they can produce a lot of it, right? But if they want to get berries, there's much less they're capable of producing. Okay. Now, in the Gatherland side, their situation is reversed. Okay, their production possibilities frontier is they can produce a lot of berries. They put their mind to it, but if they all produce meat, they're going to produce a lot less. Okay, so these two societies have different advantages. Okay, so what we call this is, we could say, absolute advantage. We define that, right, is when a society can produce more. Can produce a lot more. All right. Now let's just put some numbers on this, right? So let's say that up here we have, let's say this is 500, and up here 1500. Okay, and just reverse that. Okay, so we can see each society here has an absolute advantage, right? They can produce more than the other one, right? The Gatherland can produce a lot more berries. Hunterville can produce a lot more meat, okay? Now, comparative advantage, on the other hand, is when society can produce at a lower opportunity cost, okay? So, can produce at a lower opportunity cost. Okay, so in order to understand this, right, like we have to say, all right, for Hunterville, let's just take two simple examples, right? Do they want to be at point A or at point B, right? So point A represents, well, they're producing 500 of the berries and 0 of the meat, right? And point B, the opposite, right? 0 and now 1500. Okay, so what is the opportunity cost for them, right? If they produce at point B, well, what's the loss over the gain, right? They give up this 500, right? If we say, B versus A, okay, we give up that. The opportunity cost is 500 over 1500. Okay, so opportunity cost at point B, right, moving from A to B, okay, 500 over 1500, right, the loss over the gain. So the opportunity cost is negative 1/3 or negative 0.33 repeating, right? So, all right, 1/3. Okay, that's their opportunity cost. Now, for Gatherland, their situation is reversed, right? So for them, if they consider what is their opportunity cost at point B, so okay, again, point B. Well, to be at point B relative to point A, they would have had to give up 1,500, right? Their loss is 1,500 over their gain is 500, right? So it's a very different situation here, right? Very different situation. They -3, right? However, they have a much lower opportunity cost of being at point A, right? So point A, okay, opportunity cost, point A, that one's going to be -1/3, right? Um, the loss 500, the gain 1,500. Okay, so comparative advantage is when you can produce at a lower opportunity cost. Absolute advantage is just the total number that you can produce is bigger. Okay, so what we can see here is that each society has a comparative advantage in producing one thing versus the other, right? One thing versus the other. And so what Ricardo's argument was is the society should produce where they have a comparative advantage, and then they should trade. Okay, so by doing this, they're able to do much better than they would be able to do on their own, right? So produce where you have comparative advantage, then trade. All right. So imagine that both sides did this, right? That Hunterville produced, 1,500 of pounds of meat, and Gatherland produced 1,500 pounds of berries. Now, they're not happy with that situation, right? Because both societies would like to consume both meat and berries, right? Because come on, it tastes better to have both, right? So they'd like to have both, but each side should produce the thing that they're the best at, and then they should trade. Okay, imagine that they trade at 1-to-1. Okay, so imagine that the terms of the trade. We would have to know more, of course, to know what the price of these things is relative to each other. But let's just imagine that they trade 1 pound for 1 pound. Okay, so after they trade, then Gatherland ends up with 750 of each, right? They started off with 1,500 pounds of berries, 0 of the other, right? They take half of their berries and they trade it for 750 pounds. That's fantastic. And then they end up here, right? They are right. They are at a much better point C. Okay. I know I added a bunch of stuff to my graph, but you can see, right? We're well above 500, right? We're below 1,500 on this side, but so that is through trade, through specialization and trade, we are then able to, and I mean the same thing for Hunterville, right? They are able to be at a point that is well outside of the production possibilities frontier, right? And this represents the gains to trade, okay? So, gains to trade. So Ricardo is remembered for making an argument for why it is more efficient for societies to specialize and then trade, and again, is seen as one of the foundational arguments for free trade. Okay, that's my lecture on this topic. Thank you very much.